Yeah. Kind of like the side thing. You know? Yeah. Seems like a good setup when we like that, you know?
So anyone just joining us, we are in the Channel Islands National Marine Sanctuary, just north of Santa Cruz Island on the eastern side. Santa Cruz Island is 26 some odd miles long, and so the Nautilus has done dives on the western side of the north portion of Santa Cruz Island, and from what I've heard so far, it seems like a very similar habitat, soft bottom, but
I think
not the
that's
greatest
enough
visibility when we were a
that
bit
way.
deeper.
We're good. Yeah.
Good.
Yep. I like it. And I guess based on what we're seeing and the better visibility, maybe we could bump it a little bit.
Roger. 0.5? 0.4.
Or
Halfway. Bridge nav. Let's add 50 meters to bearing 176 and bump up speed to 0.4 knots.
Buckle your seatbelts.
I'm ready.
as long as George is out there dealing with all the fishing line covered.
Yeah.
Sea life.
So the purpose of this dive is to validate some backscatter information that was collected here pretty recently. This backscatter information is essentially an acoustic signal that we interpret to determine if the seafloor is likely soft or hard. And most of this transect that we've laid out as a plan for the route that the ROV is going to take is mostly soft bottom. So far the information is true. Heard it here first. still saying the
Now, can I get
occasional
a
basket star.
distance between our point and AY,
Sure
and then
can.
AY and the next between AY and the next waypoint too?
Sure, we're about 415 meters off of AY. And zoom out for next waypoint. And 915 meters to get to AZ.
Great, thank you.
It's actually meters per second. It's seconds instead of just really confused. Yeah. And then you have to multiply it by the joy gain. Not easy to know back speed. Yeah, it would. Yeah, we should get all those things that are really always requested. Like, what's the current speed? You know? What's the slope of the hill? Like, all those things we should come up with a way to present that.
More kelp, more sea pens. Still a lot of muddy bottom. We're seeing a lot of shell hash as well.
I guess you'd need an upward facing Doppler to measure the current. Yeah, these Dopplers are used a lot of times for measuring current flow. So they'll be mounted with the beams pointed up. There's the water mode. You can set them in, measure the speed and direction of the current. I guess it bounces off the water. Because it's the Doppler shift, so I guess you get that from the little bit of water return. I don't know the math there. Yeah, they're mostly used for that purpose. This is a novel kind of application. Yeah. Yeah. Well, it's sort of heavy. It's another thing to get hung up on the top. We really want it smooth up there. You don't want a bunch of things protruding. So, I don't know. I think there's smaller ones out. And you could probably get away with a smaller one anyway because you're not trying to get range. You're just trying to, yeah. It is another source of sound in the water that's going to interfere with, like, the sonars and whatnot. Yeah, I think you're a little bit out in front. So if you push the stick, though, you lose the XY, right? Oh. But I mean, if you have your hand on the stick and you just move it just slightly, it'll take out the whatever step you had. Yeah, yeah, yeah. No, if you move the set point. So that's all you're doing with the stick when you're in auto. You're moving the set point. So as soon as you touch the stick, you set the set point. Well, you can just look at it, just see it to go. Just move the stick. Yeah. Yeah. Yeah.
Seeing more kelp here.
Yeah.
Drift kelp is one way that these two kind of disparate environments,
Yeah.
shallow water kelp forests and the deep sea, are still connected. These kelp fronds bring in organic matter to the bottom where they're decomposed or eaten by urchins.
Yeah, I think other ROVs do things like we were talking about with the bias knob, the Z bias. Yeah, individually, and they call it like cruise. Yeah. But it will bite you because you have this knob setting in there. Forget that you have a knob setting.
little fish you're seeing kind of swim across the bottom of the screen is likely a short-spined conefish. We've been seeing quite a few of them pretty regularly around this area that we've been diving on. We've also been seeing these basket stars quite a bit too as well. They tend to like to find the small, only pebbles and rocks in the area to perch upon. We've also been seeing some eel pouts as well, which are longer fish that have these wider pectoral fins up near their head and an elongated tail and body with one single continuous dorsal fin that runs all the way down to the end of their fins.
A couple of years ago, we completed a report on the status and condition of resources within the sanctuary. We talked about all the different habitats in there and all the different resources ranging from whales to birds and algae, fishes, and invertebrates. But in terms of where the data existed, it was really in that shallow water environment. A lot of the data came from the kelp forest and shallow reef. And we found very clearly, a big gap for us in terms of understanding the sanctuary is this deeper water environment, which includes both these hard bottom features like we were looking at yesterday evening. If you scroll back in Nautilus Live, say 12 hours ago, we were over some pretty spectacular habitat, 13 hours ago even. But now we also have to survey some of these soft bottom areas and find out what's there. It's a large portion of the seafloor across the entire West Coast and around the world is soft bottom, and forms key habitat for things like flatfish. We're seeing some of these sea urchins and sea pens. Other species of fish, comb fish, as we just mentioned. So any data we get here is good and unique for a very understudied region. We're also trying to confirm what the seafloor looks like. Hard bottom or soft, rugose or fairly simple structure-wise. But it seems very similar just as we cruise along here. We do see unique little features here and there. An octopus will pop up. We saw a larger rockfish of some sort earlier on that just sit by the front of our camera for a second. So we know there's other features. The problem with these surveys is you can really only see what's right in front of you. So
just hit.
You don't know if there's a cool feature just a little to the left or a little to the right.
Starboard bucket?
But at least we see something.
That monitor. Yeah, I was just poking, but yeah, I just went for it. Yeah. There's probably other buttons that might mess you up, though. I'm suspecting. No?
So we have Di Waters in the science chat, and she's been
Now you're in the danger zone.
standing the watch shift after Chris and I from midnight to 4. And last night we were on a glass sponge reef that we discovered just south of Santa Cruz and Anacapa Passage in the Footprint Marine Reserve. And it was pretty massive. It went on for hundreds of meters, and we kind of came up a ridge in the center of it. And so when we handed off the leads to Di Waters and Lisa Vonik, we asked them to go back to see if they could get any sense of how large this glass sponge reef was, which you can go back and see by rewinding the Nautilus 8 to 12 hours. It's really impressive, and she's in the science chat now, so I was checking in with her to see if she had any idea of how big it was, if she found the edges, so to speak. And she says it went on for over 300 meters north and west. So it truly was a massive glass sponge reef. So we'll have to look at some more remote sensing data, like sub-bottom profiling, for example, to get a better idea of how big that reef really was, because we were not able to circumnavigate it with the ROV with the time that we had. So exciting discovery. We just passed quite a few flatfish just now. That was interesting. There's still a few in view too. Little tiny guys. Still seeing a lot of these small, thin, white sea pens. Less so of the Penatula phosphorea, which were the thicker, fluffier sea pens we were seeing earlier. Much more of these white ones now. We're still seeing short-spined combfish, which are the really, they look pretty darn small. They're kind of darty when they move, and they're kind of stick straight, and then you can see the fins on their dorsal side. So if you're seeing any fish like that, it's most likely a short-spined combfish. We're also seeing some eel pouts, which are also elongated, long, fin-looking fish, but they tend to be a little bit shinier, not as blotched or mottled like the combfish would be. Also found right on the bottom of the seafloor. They don't typically hover above it. They usually sit right on top of it.
Yeah. Oh, yeah.
Looks like kelp stipes that we're seeing. Those lines on the seafloor. So fallen kelp, the main stem which the blades go off of. And a whelk shell just went across the screen. More flatfish. All here in the Channel Islands National Marine Sanctuary on this muddy floor sea bottom that we're looking at. Lots of shell hash, shell fragments, organic matter from shallower in this area drift down and accumulate on the seafloor. Quite the contrast to last night's dive, but this will be valuable information for the sanctuary to ground truth the mapping data that's been collected in this area fairly recently. Some of it was collected as early as last year. And so we're processing it and analyzing it to determine what different types of habitats exist, in different areas of the sanctuary, so we can better understand, manage, and conserve the resources that fall within our boundaries. Soft bottom habitats are one of those. Chris, do you want to start another transect, or should we keep going until we hit AY, waypoint AY?
Two things. One, I was wondering, not that it would really change the heading, but AY was, correct me if I'm wrong, just selected as kind of a midpoint to get us towards AZ, but really the point is we'll be going to AZ, or is there something specifically we thought we'd check out at AY?
No, you are correct. AZ is the one with the hard bottom return.
So, Nav, I don't think it changes much in terms of our bearing or heading, but nothing specific or special about AY. So, ultimately, what we're hoping to do before we have to pull the ROV is to get to AZ, at least, if not a little bit further, along to BA. Presumably, the other ones are going to be too far for us to get to at this dive, but. So we'll keep going, and yeah, as far as the transect, we probably have time to get one done. Now, can we get one done in 45 minutes?
Yeah, for sure.
Minutes. So yeah, why not? We might as well take advantage of this time to get some quantitative data.
Okay, so shoreside, Bob just let us know that he's comfortable going to 0.5 knots if you'd like to do this transect a little quicker. Is that of interest?
Wait.
Yeah, I think so.
Stupid lasers.
If you're comfortable.
Alrighty. Okay, let's get set up then. We'll just do it while moving for a transect. Cool. Alrighty. Bridge nav. Step 200 meters, bearing 176 at 0.5 knots.
Wonderful, thank you.
Hopefully it's wonderful.
Drop a target.
Oh, thank you. Let's start the transect now.
Rightly no. Dynamic range.
Well, this transect will be easy to analyze. Not much to count here.
I might even be able to do this one.
Yeah, Chris and I might volunteer to analyze this transect for everyone.
Well, it might be, maybe there's a rock layer. There's a sub-bottom profile.
lot more drift kelp
it's
here.
probably just picking up like multiple area, right?
Another crab, kind of decapod species. We were seeing rock crabs, but I'm not quite sure if that was the same as what we saw earlier. Still seeing a lot of shell hash in these areas, which is like a collection of broken up bits and pieces of shells, other organic debris. We're seeing a lot of kelp still. And we have a partner we're working with at the Santa Barbara Natural History Museum who's interested in collecting some of these shell hash sediment samples, which we've collected one for him earlier. He's taking these samples and looking at the micromollusk that lives in between these pieces and sediment grains. And he's describing new species with new scoops because this is not a well-studied environment. And so there's a lot of new species out there to be described, especially if they're taken from different habitats. And so we've been collecting different sediment scoops for him at various depths, and some which are kind of hard to come across unless you have a specialized tool like this ROV and the scoop to do so. And so we imagine he'll be describing several new species. Once he gets around to processing the samples and spending many long hours with the scanning electron microscope. But it's important work, and we're glad to be partnering with him as well as the museum to be helping him with these collections. We're also collecting samples for several other partners on this mission, NA123 in the Channel Islands National Marine Sanctuary and the Santa Lucia Bank. We're working with the U.S. Geological Survey, who is doing stable isotope analyses on the subsamples of the corals and sponges we take. They're also looking at particulate organic matter within sediment samples and water samples. And this is for a larger study throughout the West Coast to look at deep sea food webs and to see how all of these different environments are connected and who's eating what food source and how does that travel up the food chain. And so we've been taking samples of corals and sponges primarily for genetic identification and to refine the taxonomic relationships between populations and different species. But we take a subsample from those to process for the stable isotope analyses. So we're getting 2-for-1 for almost every single sponge and coral that we collect. And we've been trying to maximize our time and collections with as many partners and research objectives as possible so we can use these resources to their maximum capacity. Studying the deep sea is a resource-intensive endeavor. Being such a remote and harsh environment, it takes a lot of people, big ships, and specialized technology to be able to get eyes on the seafloor. We're relatively shallow now at 90 meters, but so far I believe the deepest dive of this season was 3,800 meters or so. And in addition to the corrosive saltwater environment, those are extreme crushing pressures at those depths that these tools and robots essentially are experiencing. Although I'm not sure if I need to technically call them robots or not, because I think we had a discussion about that earlier, what technically is a robot, but they are being controlled and driven by pilots and engineers on the vessel, the Nautilus, the exploration vessel Nautilus. And Chris and I, who work for the Channel Islands National Marine Sanctuary, are helping guide these ROV dives from home. We have a little school of fish that we're just coming into here. Potentially half-banded rockfish, that would be my guess, although I'm not sure. We're also partnering with the National Marine Fisheries Service, and they've been, a lot of folks from the Fisheries Service have been helping us stand watches. And so with 24/7 operation, despite not being on the boat, we need people to be able to interpret the dive plans and guide the pilots and the navigator and video and the data logger to complete some of our most important objectives and to help make decisions about where we're going and what takes priority over what. And so not having a whole lot of ship time because of COVID, this Nautilus expedition has everyone really excited and happy that we've been able to involve them in the process. Thanks a lot to OET being flexible and helping us get everyone up and running with this V-Link software so we can have multiple people stand watches, because living life at home while standing 2 4-hour shifts every 12 hours is a little bit different than being on the vessel itself and just living life out there for 10 days straight. Certainly takes a village. And we've had wonderful, great support from our partners. So this has been a really positive experience.
And we have 50 meters left of this transect.
Thank you, Sam. We also work with partners like BOEM, or the Bureau of Ocean and Energy Management, who are interested in some potential wind call areas that are near Santa Lucia Bank. And they're interested in better understanding the seafloor to help plan potential infrastructure that would be necessary to collect wind energy in those areas. They also are interested in surveying the seafloor for other resources such as minerals and understanding those various types of habitats. And so BOEM has also been a great partner throughout this process. And they funded the habitat suitability models that we've been using to help guide where we're choosing our dives, they are working with a NOAA office called the National Center for Coastal Ocean Science, or NCOS. And they used a lot of different environmental data sets to predict where different corals and sponge species would likely find suitable habitat for their growth and survival and reproduction.
So we are just wrapping up this transect right about now. And Science, would you like to stop here for anything or continue on?
Do we
I think
want
we
another
can
disc in,
continue
or are we
on.
good?
I think I am, the next time we see kelp, just to make sure that we do get a sample for Taylor Ann, I think we should stop and collect, and maybe when we have to set down for the kelp, we can fire a skin then.
Yeah, okay.
Because she'll
So yeah,
also want
continuing
some
on
water.
to the next.
Alrighty.
Let's see.
We have about 830 meters to waypoint AZ.
Did you already call in the next move to George? Okay. Got it. Nice. Yeah.
So Lizzie mentioned the models that NCOS developed. Those models are, the resulting products are maps of the distribution of the deep sea corals and sponges. And they're put together by sightings data, like the stuff that we're collecting right here on this cruise. As we note on these, during the course of this video, we know exactly where the ROV is. And we note where those corals or sponges or fish are, whatever it is that we want to map. And then we can go back and relate that to a series of other variables. So maybe we know what depth it was at that spot. Maybe we know what the seafloor looked like at that spot. Maybe it was hard bottom. Maybe it was soft bottom. Maybe it was cobbly or more reefy. And since it costs so much and it's so difficult to survey all of the seascape, that's the reason we have to model. So we use that to predict other areas that might be similar in terms of their current patterns or their depth or their habitat. We'll predict that we would see similar animals and in similar abundances. And the more we know about that relationship between these organisms and those other variables, the better, more accurate those models and maps will get. And that's very, very important for place-based resource managers, meaning place-based, meaning managers that oversee a specific area.
Yeah.
One of the tools in our resource management belt is to make spatially explicit management decisions. So some activity you can do in one spot maybe, but not another, because it's not commensurate with whatever your management objectives are for that region. So in the sanctuary, if somebody wants to propose to do a specific activity or action in our environment, we'll want to know, okay, well, what's likely there? Would that action likely impact the creatures that are there? And if we haven't been to that spot, the best thing we can do is to take a look at one of the best things we can do, and one of the tools in our belt is to take a look at those maps and distributions of creatures that we think might be impacted by that decision, and say, hey, do they occur there? Could there be a potential for conflict? So it's incredibly useful, incredibly powerful tool, and similarly, our federal colleagues at the Bureau of Ocean Energy Management are responsible for leasing federal waters for things like oil and gas or renewable energy, likewise are interested in minimizing those potentials for conflict. So having those map products are really key, essential, and effective tools in resource management. If you think about planning on the land, in terrestrial systems, terrestrial environments, city planning, or planning for agriculture or anything, you just have so much more data available to you. You can just literally walk across the landscape and make note of what's there. If you think about the power of Google Earth, we have most of the surface of the Earth imaged. And on the terrestrial side, you can just zoom in and see anywhere you want and see what's there at a very high resolution. But here on the seafloor, we just see these tiny little strips as we move along with the ROV or an AUV, an autonomous underwater vehicle. So the best we can do is to take that little bit of data we have and do the best we can to predict what's going on in the areas, in the much larger extent of areas that we can't see on a regular basis.
Do you ever use AUVs or ROVs kind of on demand to survey particular areas of interest like that?
What do you mean by on demand?
Like, you know, if there's a proposal for a, you know, wind farm in a certain area, is it ever, you know, will you ever go and survey that area specifically, or do you kind of always rely on these models?
Yeah, people do. I know, for example, with the renewable energy areas, and similarly, folks that are interested, like if you're laying fiber optic cable or something like that across the seafloor, then you'll want to they typically will survey the exact proposed route for the cable. The problem with that, though, is that you don't know that 10 meters over was a better path or route. So, but frequently they'll survey that exact route as part of their environmental impact assessment. So the optimum, which is incredibly costly, and maybe you survey that route and you say, hey, it just seems like it's a no-go because of all these habitats that are there might be interfered with or impacted. So the optimum really is just kind of start with those models and say, hey, these are the areas we predict to have the least impact. Now focus your site-specific on-demand survey, like you suggested, on that region as opposed to this other one. So you go in there with an informed opinion, and you can reduce the cost for the person laying the cable or the developer for renewable energy, for example, by having those models. And then they can come in and do the much more high-resolution, detailed survey data, which might be a one-time swap if you're just looking at the seafloor, or if you're worried about how the structures, if they're going to be also have a component that's above water, might interfere, impact fishes, whales, or seabirds. You might have to do some of those surveys again and again over time at different seasons and multiple years. Really good question.
Great, thank you.
We wish we had, locally for the sanctuary, we wish we had these types of technologies more at our disposal. We have a very, very small shallow water down to maybe 100-meter mini ROV we can use to go check out an area before we dive it maybe, or get good video feeds for education outreach if we take a class of students out to the sanctuary on our boat. So we definitely have on-demand needs more than we have on-demand ability.
Yeah. Great, thank you for the info.
So pilots, we've got about 20 minutes, about 15 minutes before the handover. Do you want to just keep moving, or should I put in a ship move that will have us set down for that handover?
Well, is that a fish or kelp right there on the right?
I think we're still looking for kelp and urchins together, right?
Yeah, if you want to stop and sample this kelp.
Okay.
So we do want to sample this kelp, or we want to keep looking?
Urchins.
Yeah.
You gotta find urchins with
I think she said.
I was looking for urchins, but now I'm afraid we won't find any, so we might as well sample kelp while we can. I just don't want her to go without kelp if we don't run into any more urchins out here.
Roger. Ship's holding position.
But I do see a sea cucumber, which we haven't seen many of those so far.
And we want a Niskin in this area too? Or only if we...
Yeah.
Yeah.
Might as well. Yeah. I think we have plenty.
kind of got dirt by them.
Hmm?
Dirt going by.
I do zoom on kelp.
Yeah. Let's zoom in here, Al.
How are we going to go for this?
Taylor was preferring a slurp, but if you think it might get caught.
Yeah.
Is it floaty? Can we
frame it
just
up a little
stick it in the box?
It'll be pretty floaty.
Well,
Okay.
I think she prefers that it be slurps because she also wants to sample the water it came up with for microplastics in addition to the Niskin.
All right. Go for a full shot specimen.
Let's come wide a little bit, Al.
There, right there. All right, got it. Ready to go.
So where would we propose putting that?
If we're going to go to slurp, we have bucket 1, or we can go to the forward box if it's the crab.
Slurping it, right?
We slurped one a similar size yesterday. It worked fine.
Yeah?
Oh yeah, how did that sponge situation work out in the end? In the slurp.
It all came
let's
out
come wide out.
in the proper jar. It just, yeah, it hangs up there sometimes.
Oh.
It always comes down though. It's just a little quirky.
Okay, so jar one.
Can we zoom in just a touch, Al? Just to... Or those bubbles.
It's weird.
Yeah. So for this slurp, I mean, we want to go from one of the ends so it tries to flow through.
The one that doesn't make it hang up. So maybe get the root first.
Yeah.
Opposite end there.
All right, let's
away from you.
come wide out. You
got more hose.
Is the, oh. No, it was the